Welcome to Python Intro Day 2. To start off, I uploaded our past 2 meetings to YouTube, so they are now visible for us. If you go to the website here, then you can click on the playlist, or you should be able to, and that should have all of the videos I've uploaded. If you have any issues with that, though, let me know. It should be unlisted, but you should still be able to like link to it. But if there's any issues with that, I can change the permissions. You're welcome. And then next is the blog. I'm working on the blog this weekend. So historically, there's been a place where people can like put a written form of their talk up. And so I'm going to work on putting together last week's intro and then this week's intro into a blog post so that it is in a readable format too. So today I am going to talk a little bit about Jupyter Notebooks and Jupyter Lab and why you would use them, and maybe a quick crash course. And then we'll talk a little bit about converting types, because that was a question last time. And then I want to talk about how to write loops. And then if we have time, I'll talk about defining functions, but that's kind of an extra thing. So first, to install things, first we're going to install things. So if you looked at the this Google Drive link that I sent out, you should have seen this package installation document here. And so this has instructions on how to download NumPy, glob, and then matplotlib. And so these are the 3 commands for that. And so the ways you can install that are writing these commands either into the console area of Spider, or on a Mac, you can do it in Terminal. There's an equivalent way on Windows, but I don't know it off the top of my head, so we could talk about that later if anybody is interested in that. But the general formula for package installation is conda install and then the package name. So anything like if you're Googling how to do something in Python and it's using a package that you don't know about, or you don't have installed, you haven't used it before, this is how you can install it. Just with this simple formula, not really a formula, but this command. So if you have installed NumPy, glob, and matplotlib ahead of time, then you should be all set.
So what if it's telling me that the package doesn't exist, package not found?
As long as NumPy and matplotlib are installed right now, we're golden. So first, we're going to talk about Jupyter. And so first step will be opening Jupyter. So we can do this the same way we open Spider. If I can get up my, so we go to the Anaconda Navigator. And open. And there's an update. There always is. So you'll see that you have Jupyter Lab and Notebook. And so these are pretty similar. Jupyter Lab has some like extra functionality, but they essentially do pretty much the same thing. I stick with Jupyter Notebooks generally because there are a few packages that I use that haven't been converted to Jupyter Lab yet for some reason, for like some interactive figures. So that's why I tend to lean toward the notebook, but Jupyter Lab is the same type of situation, so it doesn't matter which one you choose, but if you want the exact thing I'm looking at, you should choose the Jupyter Notebook. You can just hit launch. And so it might, you probably won't bring, or it might not bring you to this immediately. So when you do that, terminal or some sort of window, if you're on a Mac, terminal window will come up. And so if it didn't come up with this like Jupyter page with like this file structure, which is your own file structure, check this window because it might have a URL it wants you to copy and paste, or password or something like that.
So it popped up with the website, but not the command.
Okay, that's fine. The command prompt is that I just brought that up so that if there were issues, this could be where you'd find it. But if there aren't any issues or anything and you just get this is the file structure on your computer, then things are going well. And so what Jupyter does is it uses your internet browser, so Chrome or whatever, as a host to display things. So you don't necessarily need the internet to use this. You don't need the internet at all. It just is using your internet browser as a way to look at this. But it's all local on your computer. So what I am going to do is navigate to the location of the data that I downloaded from my from this Google Drive. So there's this data folder and I downloaded that. And so in this window, I'm going to navigate there. And so I know it's on my desktop. So I'm going to go to desktop and I'm just going to go here. And then I'm going to make a new file by clicking new Python 3. And I'm going to pause here while people catch up. So this is the Jupyter Notebook, and these are pretty cool ways of sharing your code. So basically it's constructed of a series of like cells is what they're called. And so this here, surrounded by this green, is this is a cell. And so this is right now a code cell. You can tell that by this drop down here. And because it has these square brackets. And so in a code cell, we can type anything that we could type in Spider before. So I'm going to try and type and we'll see if it lets me. Okay, good. I'm just stuck with this email in the middle of my screen. But okay, so I'm just going to comment and say code cell here, because this is a code cell. And then if I want another cell, I can hit this plus sign. That'll give me a new cell. And so this again comes up as a code cell. But one of the things that's really nice about Jupyter is that if we click this drop down, we can select Markdown. And I'll try and make my font a little bit bigger. And so as soon as my computer catches up, it'll have a Markdown cell. There we go. And in this cell, we can just use plain text. Oh no. Yeah, can you tell? I have titled this document yet. Okay, but in the Markdown cell, you can use regular Markdown syntax. So if you know Markdown, you can use it here. If you don't, it's okay. You can still just type regular text. It's a, hang on, text can go here. It's a language that just like helps with text formatting. So for example, if I were to do a pound symbol and then say like, this is my title. And then when I run this cell, so if I click the run button, it will format it like text. So now we have text can go here. This is my cell. And so if you had like some analysis you wanted to write, or like a list or a table or whatever, you can put all that kind of stuff here, or links. And it really helps with documenting things. And especially if this is something that you want to give to like your advisor or something like that, it's nice to give it some context. Yeah. So that's my favorite part of a Jupyter Notebook, is that you can insert Markdown into there. So a little shortcut is that if you want to run a cell, you can hit Shift, hold down Shift and hit Enter, and that will run your cell. And so that's typically what I will do throughout, and I will bring that up, but that's how I run cells. So just like we learned last time, we can say like A equals 50, we can print A. And then if we run this by holding shift and hitting enter, we get 50. So this is the same as what we did last time, just in a different place. And then our output is always displayed underneath our cells. So last time, one of the questions was how can we convert between types? And so I wanted to talk about converting integers to strings. So we have an integer up here, B, or A is an integer. So if we can say type A, so we know it's an integer. And if we wanted to convert this to string, we could say B equals str A. And so what str does is it tells it that we want strings. And so if we hold shift and run that, nothing happens, but because it's stored in a variable. But then we can see that our type is now string. So to convert between integers and string, all we need is this str command. But now if we want to try and do math with this, so say 5 plus B is our string. We can't because one of those is a string, even though it's a number. Python recognizes that we have converted it to a string, so we can't add or do anything with it. So that's how we can convert between strings, and similar thing with integers and float. It's just this easy command, or int for int, or float to convert to float. So that is our conversion between floats and integers and such. So now I want to talk about loops, which is what I think is one of the more exciting things to do with Python. So first, we are going to define a list in Python. And so to do this, we're just going to say A equals, and then in square brackets, I am going to list my odds, 1, 3, and 5. And I'm actually going to name this variable odds, not A. Bless you. And so I'm just going to put odds and print out odds so we can see what that looks like. I misspelled this. There we go. So now we can see we have odds, we printed out odds. But say we only wanted this one value, this value in the first place. We can index with Python using square brackets. So if I say print odds, just like I did before, but then I add square brackets and I put a 0 and I run that, it gives me this 1. So Python starts counting from 0. And this is something that's important to keep in mind whenever you're doing any sort of like subsetting or anything in Python, is that you always consider this the 0th spot. So we would count 0, this is 1, this is 2. So we always use 0 as that first spot. And that's not the same throughout all programming languages. So it's something that's good to keep in mind. So if we wanted to print out all of the odds, we could do something like this: print odds 0, print odds 1, and then print odds 2. So when we do that, we run that, and we get all of our odds. But this isn't necessarily the best way to list all of these values, because we need to type this every time, and there's a lot of space to mess up. Like I could have mistyped one of these letters, I could have misspelled one of these variables, which I did. So we saw that that's a very easy mistake to make. Or I could miscount. So say I said print odds 3 and ran this. Now I'm getting this error because in third place, there's nothing when we're counting from 0. So what if we wanted to do this with a changing variable, a variable that we're not really sure how long it's going to be, or a variable that we might change? It's better to do this in a loop. So to do this, let's make another odds variable. So we'll say odds equals 1, 3, 5, and 7. So we added an additional odd here. And so to list these all in a loop, we're going to say for num in odds, and then a colon. So this is how we always start our loops, is for, and then we have this variable name that could be anything. We're going to use num in this case, but I could make this be Sarah or monkeys or whatever. And then in odds, this is the list that I am referring to. So in this case, it's this odds list we made up here. And then we always need this colon at the end. So when you hit enter there, you'll see that Python automatically indented it. So Python knows that now we're writing in this loop, and that indentation is important. If you get that indentation wrong, Python will recognize that it's wrong, and it'll either give you an error or it'll think that you want to do something that you're not. So now I'm going to just write print, and then in parentheses, I'm going to say num. So I'm just printing out this num variable. And now I'm going to run this. And we can see that we have all of our odds listed here. And so we can change this. I could add 11. I could even add something that's not an odd, and then rerun it, and it still is going to change to be the specific length. So basically what this is doing is saying that num equals the first one of this, and do this loop while num is equal to the first one of odds. And then once you're finished with that, we're going to move on to the second thing in odds, and we're going to name that num. So it just takes turns going through every value in odds and making that equal to num. It said in Python that it's a what? Oh, what's telling it that it's a loop? Okay. The for and in is what tells Python that this is a loop. You notice when you type for, it turns green, and that's telling you that Python has, like, it's translating that into something like in its brain. That was a terrible way to say that. If it turns green, it's recognizing it as something, and it's going to do something special with that. Just like how if we type print, it turns green because that's Python's command. For is kind of what lets it know that this is a for loop. And the same with in goes with for as like just words that Python knows. So that is how it sort of knows the for and in. But also this colon is pretty important, because if I were to type for num in odds and I don't do the colon and I hit enter, it doesn't automatically indent. So the for and the colon are really kind of package it together. Exactly. Yeah, so if I'll do another example in a minute where we will do some addition in it, and you'll see that yeah, as it loops, you can do a number of commands. So the like formula for this is for variable in collection, colon. And so if you run that, you'll get an error because we don't have anything called collection. But this is the general formula for loops. So I'm gonna add another thing, go down. And so now let's write a little bit more of a complicated loop. And so I'm gonna have a loop that counts the numbers of names in a list. So the names in the list, I'm gonna have Python, R, and MATLAB. Whoops. And so these are all strings. This is a list of strings. We know they're strings because they have these single quotes around them. And you might have noticed that I messed up in the beginning and had double quotes around one of them. And that doesn't really matter too much if you're not doing things with, it doesn't really matter too much. Just don't mix and match them. I would say I try to use these single quotes, but sometimes if you're defining a string that has a single quote in it, you need to use the double quotes. So there's a place to mix and match them, but generally try not to. So now, because I want this loop to count, I'm gonna make a variable called length. And I'm gonna say that that's 0. So next, I'm gonna say for value in names. So now we're gonna write our loop. We have our for, and then value is the variable that I just decided to use here. You could use anything here. You could continue to use num. And then in names, so we have these are the names. And I'm just gonna say length equals length plus 1. I need to spell length correctly. Just a little. Oh, you're right. It is still wrong. It was just a big mess of a word. So now it's going to set value equal to Python, and then it's going to do this. Length equals length plus 1, and then value equals to R, length equals length plus 1. And so it doesn't reset length ever. Just note that there's nothing in here telling us to reset the length. So now I'm going to say print, there are, and then comma length, comma names in the list. And so this is how we can combine a variable and strings in a print statement. Length is a variable. These are each strings. Yep, because if you did put the single quotes around it, it would think it was a string and it would just say length. So now I'm going to run this, and we see there are 3 names in the list. And so it counted them correctly. Each time it went through that loop, it added 1 to the value length and counted the names. But we didn't tell it to print out the names or anything, so it's not printing the names out or anything like that.
And plus 1 is just counting at 0.
Yes. Yeah, and each time you go through it, you want it to add that 1. So to make it a little more clear, I am going to rewrite this with some other print statements. So I'm just going to steal pretty much the same code from before. I have our names, Python, R, MATLAB, and I don't necessarily need to define these because Python knows them, but I'm going to do it anyway, just for to be thorough. And then I'm going to have for value in names again. So this is identical to what we had above. But now I'm going to have it print the current name is, and then I'm going to have it say value. So when it starts this loop, I'm going to have it say what the current name it's working on is. Then I'm going to have it do this length addition, just as we did before. And then I'm going to say the new length is length. And so each time it goes through this loop now, it's gonna tell us which name it's on, then it's gonna do the math, and then it's gonna tell us that new length. And so I'm gonna run that. And we can see that when the name is Python, the length is 1. When the names are, the length is 2, because it's doing that math within the loop as it's setting those equal. And so we can now say print value, and our value is still MATLAB. So now that this loop is finished, that value just remains the last of the list of names. And so this is also a good way to demonstrate that these values, even though they're generated and modified in this loop, can still be used outside of the loop and even in cells outside of it. So now we're going to use NumPy and matplotlib first. So if you installed those two, you should be good. So I'm going to say import NumPy as NP and import matplotlib.pyplot as PLT. So this is importing these two packages. We talked about this a little before, and the as just sets it as a nickname. So then I am going to set a variable called data. And I'm going to say equals np.load txt. And then fname equals, and then in parentheses, you're going to put the path to your data. So if you navigated to your data when you were on this page like I did, so if you have your notebook and all of these CSVs in the same, that's fine, that's great. And so then you don't need a path, you can just write inflammation -01.csv. And then, like we talked about before, we need that delimiter. And that's a comma. I hope I spelled that right. And then I am just going to print the data to make sure I got it in correctly. And I did. So now I'm just going to make a figure out of this data. We talked about this last time again, but it's nice to sort of revisit it. So I'm going to say plt.figure. And so what this does is it starts up that figure window. And then in parentheses, I'm going to say fig size equals, and then 5, 5. Then I'm going to say plt.plot. And so I'm going to take the mean of some of this data. And so I'm going to say np.mean. And so what this is saying is from NumPy, use the mean function. And then I'm going to say data, because that's where we have our inflammation data saved in. And then I'm going to say axis equals 0. And so that just means to take the mean over all of the rows, I believe. And then lastly, I'm just going to give it a title, say average data. And I'm just going to run that, and we will get a figure. So the next part is using glob and making a series of figures. So I'll just do that for us quickly, and then we can be done. So this is the code we just did if you are a little behind. So now I'm going to import glob, just like we imported NumPy, but I'm not going to nickname it as anything. I'm just going to say import glob. And so what glob does is it looks in your file system and lets you use essentially like a wildcard character to see all of your files. And so what I mean by that is I can say print glob.glob, And then I'm just gonna say asterisk.csv. And run that. And so these are all the CSV files that are in my folder that I am currently in. And so this is nice because now I can loop through these files and create this average data figure for each file. So the way I would do that is I would say file names equals, and I'm going to use the sorted function to make sure I sort my file names. And then I'm just going to say glob.glob. And then I'm just going to say asterisk.csv. And then I can say for file name in file names, I'll print my file name. And then I'm just going to grab this plotting command up here and put it in here and make sure everything is indented because that's how it knows to do it in the loop. I didn't load in the data. So you just need to put up here data equals np.load text. Fname equals file name. Delimiter equals comma, just as we did before. And then the last thing we need to do is close the figure because if we don't, Python will probably keep plotting on the same figure. It's just good to let it know that we're finished with this figure. Or we're going to show to tell it we're done. And now we just want it to show. And so now I'm going to run that and it loops through. It's pretty quick. It loops through. It prints the file name, loads in the data, and then gives us our average data figure. And so we have the average figure for each file name. So something's going on here. But it gives us all of those. So that's how you can use loops. They can be intimidating and overwhelming sometimes and hard to wrap your head around, especially if you have multiple loops within one another, which happens kind of often. But I hope that this helped at least a little for your understanding of loops.